one's easy. Number 3 is pretty
Yep.
self-explanatory.
Yep.
Ah.
And whatever else we won. Whatever else one. That one's, yeah, the third one's going to be tricky.
Okay. So it says the cosine between two vectors is equal to v dot w over the magnitude of the vectors. Okay, so yeah. Okay. But so we're not using v dot w. We are doing v dot w. Epic.
Man, I get distracted so easily.
All right, so here's what I'm thinking.
All right.
This is what I'm thinking.
I'm linking the stream in chat.
You get a lot of viewers?
No. Nope. But I think it's funny. All right.
Okay. I put it in problem 2.
What's
Guess.
problem 2?
We're at what 2.4?
Yeah,
We're on 2.4.
I get it. I'm following you so far.
Okay, so you see what I put there? Yeah? Yeah.
Yeah.
And then we have to solve for m.
Why do you have the negative angle again?
Because the negative angle is going the opposite direction from v to, so if you're going right now, it's the angle between v and w. If you since it's reflecting over v, it's the same as the negative angle between v and w.
Can you just write that out? Why don't write the symbols? Just draw me 2 lines.
Yeah. Okay. Give me a second. I gotta find a straight edge. Let me draw it out real quick. I got you. Alrighty. So.
I just asked Dr. Smith if we could stream it. Ask and do now ask for forgiveness later. All right. So we have some angle. Wow, a drawing tablet would actually be so good for a math major. I wish I wasn't broke. So if you negate the angle, Let's say this is 20 degrees, and let's just rotate. Let's rotate W so that it's in line with the x-axis. And we can do that because we can rotate V the same way. So it should function the same as if we were looking at any line above the x-axis. So when we're drawing a picture, we can just use that principle. So when you make this angle negative.
All right, look at the
don't know
problem
why
2
it's-
chat. I uploaded a photo of what I was trying to explain with math symbols
Alright.
with
I
a
don't
picture.
know why it was so hard for me, but whoa. It's over W, isn't it? Oh, it's across V. It's across V. Okay. Yeah. Yeah. I don't know why that's so hard for me to understand, but you reflect that over that, and that's it.
Yeah, which is a
that
negative,
it?
which gives you negative theta. Yeah.
Or is there something that we're missing in 2 dimensions, or in 3 dimensions?
No idea.
No idea? That's not... Alright, well, let's think about it then.
Because if you only have
Commentary
two...
on test
Okay,
one. Oh,
okay,
he
think
just
about...
emailed us. He just emailed us. What do you say?
I cannot stream the chat.
No. I hope not. I actually just checked his Teams after you said that. Right, let's see. Riley Jackie, no. Okay. Please see this video where I try to address some concerns about test 1. Oh, you guys already watched that. Right?
Yeah, that's the one I was trying to explain before.
Alright. I think you explained it well. Okay. Why does it take so long to understand something? How do we make progress on this? We're reflecting that. Reflect W across V. Show that V cross M equals W cross V. Alright. I'm assuming we're using W from earlier, right? What is that?
Yes. Yes, we are.
Everyone in my group agrees, so
He's got chat.
I gave him the link, so he might tune in.
Should we go back to talking about salt content? Saltiness of video games.
Maybe. Let's figure this one out first. And when our minds get numb, then we can go back to that.
Okay, before my mind gets numb, I want to move on to a different problem that we might actually have a chance at solving.
Like this one? Whatever. Maybe it'll come back to us later.
Honestly, we probably should just do that.
Let's just.
Because if we're going over problems tomorrow in class too.
Okay.
What? We are? Since when?
Yeah.
We just talked about this.
I don't think he was here for that. The email he sent, he said he explained what a bunch of shit for 20 minutes, but in the email he said that we're gonna go over problems in class tomorrow, the whole hour.
Should we start on 4 then? Let's look over for them and let's just choose the one that looks cool. 4 looks pretty cool if you ask me.
Let me.
5 deals with parametric curves. Those are pretty cool. Consider the function. I feel like we should have started with 4, 5, and 6. They all. I didn't read any of the problems, but they seem.
For keys to Chrome.
Just 4? You want to start in 4?
Yeah. Sure. Yeah. Sure. Yeah.
Okay. Let me pull this up. Oh my god. My test is being opened or viewed by Microsoft's latest browsers. I don't even know what it's called. PDF. What is... It's like Microsoft Infinity. It uses Chromium. And so it took me a while to realize where the test was. So consider the curve with time domain, negative infinity is...
What does logistic function even mean?
Less than... Well, he said we should look it up. It'd be helpful too. What I think is, what does it mean that you're that you're strictly less than negative infinity? I suppose you can't be equal to negative infinity.
A logistic function or a logistic
How do you
curve
have
is
negative time? Anyways, compute the velocity and acceleration of the curve. So we just take the first derivative and the second derivative. All right, I'm on it.
All right.
I wonder if it's okay to show the test on the stream or not.
It should be.
Yeah, nobody's watching anyways.
I figured it out. Did it. You did it.
All right, well, wait for me.
You already figured out the derivatives?
No, I figured out 2.4.
What?
Okay. Well, I knew someone could do it.
Post in chat. Pixar, it didn't happen.
I mean, yeah. 1 second, I gotta finish writing this out.
It was a good try.
Pixar, it didn't happen.
First derivative. Let's go.
Derivative should be pretty easy.
I wonder, at some point I could have probably...
Did this by hand?
No. I knew something about the complex form of cosine. It's like e to the 2i plus... No, e to the 2 what? X? Or e to the 2i plus e to the... I don't know. But let's just take the derivative. There's a t in the bottom. It's component by component. Integrals are kind of fun. I hate when I forget the tricks to them though.
Well, you're probably thinking of like, what is it? Like e to the pi I plus 1 equals 0, which is the same as I cosine x plus sine. That's cis notation. So that's cosine plus I sine something equals the same thing as e to the
I got it.
ix.
That's correct. All right.
That's cis notation. Yeah.
So the integral of 1 over x is natural log x plus c, right?
It could be.
And I'm assuming this one will be a little bit trickier to do. So I'm just going to see if I can graph this. I don't want Desmos calculator. So what is oh, this is a constant. Oh. So if we want to find the area under the curve,
Bro, we're doing the derivative, not the integral. What are you doing?
thank God you told me that.
Did you not remember that?
Told me that. No. I don't know why, but I am just missing shit. I am just not like. It's just subtle. I'm just minor things. I don't know how minor it would be in terms of this test, but like, man, how the hell did I screw that up? All right, the derivative, that might be, well, I don't know if it might be easier, but thank God you told me. So we can think of I don't want to look it up right away because I feel bad about it. But I mean, and eventually just do it to every single one. What, this way I can tell myself I tried. Just out of curiosity, can I just assume that the all the ones go to the t power as well, or does that alter things?
It alternates things.
How though? Because t1 to the t will always be 1.
I mean,
we
yeah.
can separate the bottom terms, can't we? Something decomposition. That was a long whatever chapter, long solution. Logarithmic logistics function. Did you find anything on it?
It looks like an S.
Common S-shaped curve. So this is like used in photography. I know for sure. Curves maximum value. Is it the maximum value? Oh, okay. That's cool. Sigmoid's midpoint. Wow, Wikipedia is actually savage. The standard logistic function has an easily calculated derivative. Yeah, I'm streaming math, Stefan. Yo, how did you find me, Stefan? What? What? Are you following me? Thank you
What I missed.
for noticing when I'm on YouTube. Oh, my friend Stefan's watching us do math. I don't know how much longer he'll be watching. But I got a viewer. Okay.
I'll watch to see what you're doing.
Anyways, Wikipedia is savage. They say the standard logistic function has an easily calculated derivative. Alright, it probably is easy. So we can say... Oh, but our problem isn't... Is it negative?
I'm not gonna lie.
It is negative t. Look at this. I actually am not... I actually missed the tiniest things. So it's negative t. I have positive t written down.
Wait, go back into that other one you were just in.
What other one?
Did you close the tab? Okay, I was gonna say no, don't close the tab. That's
The graph?
no, the logistic
The task?
function thing. No, the logistic function. I can go into Wikipedia myself.
Yeah. Oh, I can share the link too if you want.
Oh, I
I'm
got
having
it.
trouble
Darn.
finding it. F of x equals 1 over 1 plus e to the negative t.
Yeah, but instead of having a 1 in the numerator, there's a 3.
Yeah. What? Just take the 3 out.
You right.
Yeah. Can you help? If you have math, I can help you. Oh my god. Stefan just pulled a math pickup line on me. Alright. Let's see.
So I got the derivative. Not using the thing.
Alright, not everybody's Albert Einstein. I'm just...
Because
I feel
photo
like I
math
should
is my
narrate what I'm
best friend.
thinking more.
Photo
I
math
just
is my
stared
best
at
friend.
this photo math.
Yeah.
Let's see. I just stared at the problem for a little bit, like completely forgetting that I was, like, I'm trying to understand how 1 over 1 plus e to the negative x equals e to the x over 1 plus e to the x. But you just multiply everything by e to the x, right? Or e to the t. And then e to the t over t equals 1. And then you just get e over t. E over 1 plus e to the t. So I see that. And then you just take the derivative of that, and it's just low d high minus high d low, right? So low d high minus just e to the t minus high d low. Derivative of that is e to the t, right? Am I not going insane? Over low squared. Get e to the t plus e to the
A seagull in somebody's mic?
minus e to the t squared. What?
Can you hear that?
Yeah.
There's like a seagull sound.
Oh, okay. Oh, yeah. My mic's kind of good. There is a bird out there. It's either a
It's
bird
like-
or a squirrel. My window's not even open. Yeah, I don't know how to really work the mic's gain very well. I apologize. Anyways, we get e to the t over 1 plus e to the t squared.
I'm sorry, were you
I,
asking a question?
What? This video, Stefan, I'll play it. This is a video that my friend showed me, told me to listen to when I wanted to get pumped up. It's very hype. But anyways, I gotta focus on this. And let me know if the sound's not working or something. I'm gonna try and see if I can pick up the pace a bit. So, was that, what just happened? Was that a laugh?
Sneezed.
That was a sneeze. Bless you.
Yeah.
So, 1 f of
Drink some gamer juice.
equals. What is your gamer juice?
Mountain Dew.
Well, you eat salt, so I was curious.
It was the only food I had around me, believe me. If I wanted to eat something salty, I'd eat like peanut butter cups or something. Sweet and
Salted
salty.
nut rolls.
I also eat
Those
pistachios.
Those are so good. Pistachios are good.
Love me pistachios.
They're good.
I love like salted caramel.
Who doesn't? Alright, so we go.
I love cheese too.
The T. 1 second. I'll listen to you when I'm done working on this. This is just a derivative. Why is it taking me 10 minutes? So basically, 1.1 is going to be 3i e to the t over 1 plus e to the t plus 4j e to the t plus 1 plus e to the t. Okay, did you hear me? Did you get that?
I heard it, but I didn't memorize it.
But you have it written down somewhere.
Yep.
Alright.
I got 3e to the t over e to the t plus 1 squared. And the second part is 4e to the t over 1 plus e to the negative. Oh, is it? Oh.
No, just e to the t.
Yeah, actually e to the t plus 1, yeah.
Oh, squared.
Squared.
Squared, that's right.
Squared, all of it squared, yeah. Well, not all of it, just the denominator. Now we gotta find the derivative of that to get acceleration.
Yep.
Let me write this out very pretty.
Okay. Acceleration. So we just need to take the derivative again. Okay, so I'm just gonna call P of x et. Well, P of t.
Oh, you gotta do low d high minus high d low in this next one.
M of
fudge. Oh god.
T
I don't want to do that.
P of T equals plus P. Okay.
Isn't the derivative of 3e to the t still e3 to the 3e to the t?
Yeah, just take that out to begin with, and for same for the second one. Just multiply the results by 3i and 4j. I like taking it out and representing the e to the t on top as p of the t, representing division as m of the t, and then representing 1 plus e of the t as another function by itself, and then just doing like p of e to the t divided by 1 plus e to the t equals p to the t times m of v of t, and it makes it a lot easier to see what should be going on, because then I'll just solve for those functions rather than and then plug in the values later. Okay. So
You still with us, Nate?
Yep. I'm getting there. I thought I had it, but I messed something up. Gonna get it for you guys. Just wait.
the derivative of 1 over t is just negative 1/2 times, or negative 1 over 2t squared, right? I hate how I'm asking that. That's probably right.
How do you do the dot? Do you put the dot just straight over the r? I forget where you put the dot to signify the derivative.
Like an apostrophe? What do you mean?
Like he used to put like the dot in like a triangle format if there was like 3 of them.
But that's
two.
that's for a gradient.
What? No, that meant derivative, bro.
In a triangle? Well, write it down for me, so and then I'll look at it.
Let me imagine what I think it was supposed to look like. Okay, that's the first one.
The
All right,
chain.
this is-
Quick, give me an example of the chain rule. Just as a refresher. What, cosine 2x? Cosine
Is
2x
equal
will
to the
negative
cosine of
2 sine x, sine 2x?
yeah, times the derivative of the outsides. You work outside to inside, multiply by the inside.
So negative sine of 2x times 2?
Yes.
All right. So.
Correct, Mungo. I agree.
All right. So our answer should end up being e to the t times 1 over e to the t plus 1 plus
No, I just posted a photo in problem 4 because that's where we're on. Did I do the dots right to signify the derivative?
Okay. 1 second. All right. I'm looking at it now. Problem 4. Dots. Oh, he was talking about dots, wasn't he?
Yes.
But normally people do apostrophes right before, and then the dot. You know what? As long as you just say derivative, he knows what you mean.
Yeah, I'm sure he'll understand and
I think he knows a little bit about math. I could be like, I'm pretty sure he can connect the dots.
LOL. Funny joke.
Yeah, I would accept that. I do apostrophes.
As a person who is not a math teacher, I would accept that.
All right. So, are you? I know I've taken forever. Have you completed the acceleration? Because I'm ready to share my result.
I'm just gonna post my result in the problem 4 chat because it's gonna be too hard to just. There, I posted it.
I could go a lot faster if my brain wasn't dead right now.
Yeah, me too. I feel like there's times where I'm just in the zone, and it's just I can't control when those.
I keep like zoning out.
I feel you. You posted the results. Let's see. T to the 2t. I have negative here. You have negative there. 3 down here. I must have forgotten something. You have a 3. What do you mean by the Hebrew of math, Stefan? Just
the what?
He said the Hebrew of math. I don't know what you're referring to.
When did I say Hebrew of math?
What, no is your name Stefan too? No, my friend's Stefan. He's a viewer.
Oh, okay. My name is Steven. My name is Steven.
I said Stefan.
Okay. That's like Hebrew of math. I don't remember ever saying
Problem
that.
4, first picture. Alright, let's look at that. Oh yeah, just the dots above the letters. Yeah. There's a 3 in the bottom. Let's see.
Cube at the bottom.
Did I? Yeah. You have a cube down there, and I had a 2 down there at some point. Why can't I focus?
I'm just gonna say, this is what Photomath told me.
Shh, you're on stream.
Shh, this is what Jesus told me.
Yeah, yeah. That's
Higher power.
Hebrew math.
Well, explain it to me. If you utilized a resource, which you're allowed to do,
Yeah.
you can you explain it to me? You should know. You wrote it down.
Okay. Let me
Teach
explain
me.
this to you.
Lend me your knowledge. Lend me your knowledge.
Give me a hot second.
Wait,
And
there's folders in Discord? What?
Yeah, you can make a folder in Discord.
Oh, no way. Okay, well, back to what you were doing.
Okay.
That later. Thank you for pointing that out, Stefan. Let me know.
I mean, this thing literally just says simplify the exercise, so it should just be simplification from what I had before, but I don't want to do the math to do that.
Well, you just do it quick.
Oh, fine. God.
The wise words of a mega corporation.
Do it quick.
Just do it.
Oh, okay. I see what you were doing there.
I didn't show you anything. You're intimately talking with your computer. I see. Alright. Oh, you're saying you just got what I did with the Nike reference?
I didn't. I got that earlier.
Anyways. If I had a drawing tablet, I would like live show you my thoughts right now. But my phone camera isn't working, so I can't even show you my work. This is it's a derivative for God's sake.
Yeah, this is trash.
I didn't say that.
You didn't have to, I did.
I said it for you. Stefan, when are we going to go to Culver's again?
I work at Culver's, did you know that?
Yo, Stefan, we could meet Steven at work.
I work at one in Green Bay, though, so you'd have to go all the way to Green Bay.
Yeah, I'm down.
Go to a Packer game.
Yeah, go to a
Wait, okay, so negative 3x times x would just be negative 3x squared. Is that right?
I'm not seeing where you get the 3 in the denominator. I'm not seeing where you get the cubed.
Give me a second. I'm simplifying.
Take your time. When are you taking Math 180?
Which one is that?
Foundations of the Language of Mathematics.
No idea.
Take that ASAP. Because once you take that, then you can take so many other classes, and it's really the next level. I don't know if next level is the right word for it, but...
Well, I kind of was thinking I need to take linear algebra, you know.
It's very eye-opening.
Is it linear algebra? I can't remember which.
Linear algebra, that's like 275. Highly recommend that too.
I have to take that for my computer science course, so I think that was the one I was going to do next semester. Oh, theoretically, I could take 2 math courses at the same time, although I wouldn't want to kill myself.
No, we don't want that.
It's a bad idea.
Yeah, that's what English is for. Okay. Okay. Making any progress on the...
I'm making progress, believe it or not.
I'll show you. I'll show you what I did. I'm just gonna. It's gonna be a crappy picture. I'm gonna have to reverse it.
All right, I did it, boys.
Which one?
I'll post a picture real quick. That 2.4.
$2.4. You've been
Yep.
working on 2.4 this entire time?
Yeah.
Where we gave up, he.
I couldn't wrap my mind around it. Took me a few tries.
And you did it over all of us talking too. Okay, let's see. I'm sharing a picture with myself.
When you raise an exponent to an exponent, you just multiply exponents, right?
Yeah.
Yes.
No, well, multiply x. You can bring it down to the front, or you can. Or are you saying when they share bases, like e to the x times e to the x?
Don't worry, I figured out my
That'll
answer.
be e to the x squared.
It's not e to 2x.
No, e to the 2x. That'll be e to the 2x.
Yeah, that's what I wanted to know.
Thank you for your. It was one of those.
It's a team effort.
Yeah. Whenever I come across that, I always do like, okay, what's 2 to the power of 2 times 2 to the power of 2? Alright, what's 2 to the power of 2 times 2 to the power of 3? And then that helps me figure out what the properties are every time I look at them. Okay. There. That's my current work. Is there something wrong with this?
Give me a second.
Alright. Got the product property. Here's the chain rule. Then I just this if you're looking at, tell me when you're looking at it.
I probably won't be looking at it for like a little while. Oh, fine. I can look at it right now. Just give me a hot second. And you posted in what problem for?
Yep.
Okay, I see it. Yes. What are we looking at here?
So just look at this up here.
When you say this up here,
I'm circling my mouse around it.
are you streaming right now?
Yeah. Oh yeah. Go to the stream on. Do you want it on YouTube or Discord?
I can go to the one on YouTube. Give me a second. I already have your stream up on YouTube.
Yeah.
Oh, okay. Circle it.
So this thing right here.
No. Just you can just do it in. I'm watching your YouTube stream right now.
Yep. It's delayed a little bit. I don't know. I'm not gonna fix it. Right here.
Yep. Okay.
So I took the derivative of this. Is this right here the derivative of this? Or did I mess it up?
I don't even know what the hell that is.
What? Yeah, you do. You know how to
What
do
what
it.
is PT times M times V of t?
Yeah, let's just look at it just like that. What is the derivative of P of t? P of some. What is the derivative of something times something? It's the it's the derivative of the first times the second plus the first times the derivative of the second.
Okay,
And there's
yes, I
something in the
understand that.
middle. The derivative of the second is going to be have the same inside times the derivative of what's on the inside.
Okay, is M a constant?
It's a function, and they're defined over here.
So there's three functions?
Yeah. This way, this is the answer, and all I do is plug in these.
Where did you...
So where does the 3 come in?
Where was your 3 to start off with?
What are you guys talking about right now?
Is there a 3
Oh,
in
it's
the
okay.
denominator over here?
Give me 1 second while I simplify what I'm doing, and then I can show you exactly how I got where I'm getting.
Oh. Did I do
Is
the
that okay?
derivative wrong? The first
What are you guys
derivative?
solving for right now?
Acceleration.
What'd you get for velocity?
Velocity, we got e of t over 1 plus e of t.
Squared.
Squared. Oh, that might change things.
Oh my gosh, you're kidding me. You didn't do the squared?
Where that might change things. I didn't do the square. I should
Yeah, because
have,
your v of t should
yeah.
be e to the t plus 1 and then in parentheses squared.
Yeah, there we go. There we go. And you see, this makes it super simple to fix. Okay? In parentheses, not super simple, but okay, put it in parentheses. That means the derivative will be 2e to the t. Not as simple as that. Not as simple as that.
Definitely not as simple as that. You got to use the chain rule for that
Yeah,
word. No,
yeah.
that-
Well, I'm just going to expand it. 2e to the t plus 1. Then the derivative of that is going to be wait. E to the t to the power of 2, is that equivalent to 2 times e to the power of t?
I'm sorry, could you repeat that one more time?
E to the power of 2 t to the power of 2 is equivalent to 2 times e to the power of t.
No.
No?
If you're doing... Okay, so let me write out what you told me word for word. And then I'll tell you what it's equal to. Okay, this is what you told me. Give me a second.
I know what it is. It always takes me a while to figure this out. The derivative of e of t to the 2 is going to be...
This is what you told me.
Times e to the t to the 2.
This is what you told. The first one is what you told me, and the second, the one out. Oh, that is the answer. That's what I heard you say.
Did you post it?
Yeah, it's in problem 4.
No, I meant e to the power of t to the power of 2.
Oh, then it's just equal to
And
e to
then-
the 2t.
And then the derivative would be 2t e to the t to the 2. Yeah, but I know where I went wrong now. And because I did it this way, I can just plug in my variables again and not have to erase and do all that kind of stuff.
I gotta take my headset off for a hot second so I'll be able to hear it.
Okay.
Yeah, I was right. I just spent like solid 15 minutes redoing all my work.
But it's satisfying, no?
I guess. It is cubed in the bottom though.
Yeah, I'm slowly coming to that conclusion. It's just one little mistake.
Scratch your blood. Drop of blood. Sorry, I got the
Right,
quote
so
wrong.
So you just cancel one on the top and one on the bottom.
Yeah, which
Yeah.
gives you 3. Believe me, that simplification is a pain in the butt.
Not for me.
Well, I like
I did
multiplied
this
everything
way.
out. You know what? Shut up.
All right, let's go. Problem done. I took forever on it, but who cares?
I spent an entire page on the first problem.
All right.
On the first subset of this problem.
That is not what I want to hear.
It's a person. It's a people thing. I feel like this problem should be done quicker. It's just I don't know why it's not happening that way.
I feel like I need to drink water or something. I need to drink some liquid.
I've been just sitting here.
Drink up.
I haven't even started 4 yet.
Well, you want to just
Hey,
look
take
at
your time.
our work and do it?
You know, we don't want to put them to sleep. We still need
It works for
them.
me. I could try working on another problem too to get a little bit ahead.
Oh,
Is-
divide and conquer, you say?
Okay, velocity is the same, similar to speed though. Who joined the chat?
Hello.
Yo,
Hello.
what's
Hello.
up, Anthony?
How's it going?
Good.
Going.
It's going good.
Speed, because that's position.
You know the tortoise and the hare? We're the tortoise right now.
In the end, we win. But right now, we're just losing.
Right
I'm a lot farther than some of my other friends in like the other sections. Like apparently they were really struggling.
Are you kidding me? We got to
Dude.
1 through 4.
We're struggling, but like, I'm not lying. We're the tortoise. We have spent forever.
I mean, honestly, I think this is pretty impressive. Like, some of my buddies that also have like, I know I have 1 of 5 done and 1 of 6 done, and then so I think honestly we're doing pretty well compared to like I don't know if you guys listened to what he said in the email he sent out, but I think we're doing pretty well.
Wait,
That's
he
good.
sent out an email?
No,
Yeah,
yeah,
I
that's
was,
that
I
video.
was playing it to Colin when you were gone, but yeah, it's like a 20-minute email he sent us, just explaining like a bunch of stuff.
I did not read that.
Just that he doesn't like expect many people to do really good on the test, and like the grading system is wrapped around kind of that idea of
Wait, so he's gonna basically grade this on a curve?
I don't know if he said that, but like his Gale is like a 50% is a D or something. He said.
That's still terrible.
Yo, I can get 15% in my graphics class and get a D. No joke. That's how he curves it.
15.
15. You heard me right. Yeah. 92%'s an A, 50%'s a C, and 15 is like a D or something. I didn't get a D. I didn't go there, but that was a scale. I didn't
Incredible.
test it out.
Now I gotta use the restroom. I'll be back.
Yeah, he's very lenient. I like this style. Well, I'm comfortable helping others if they want help, but I don't know how much help I'm allowed to give, and I don't know how well I could give it because I'm just barely understanding this myself.
I think I'm just gonna wait for the picture to pop up and then I'll try to understand it then.
What do you mean, wait for the picture?
I'll wait for Steven to post a picture of his work.
Well, let me know. I'll help you walk through it with the derivative. He
Well, I
suggests going to this
probably
wiki
do it.
page.
It's just I'm lazy right now.
No. Let's do it. I got the wiki page for you. Go to my stream. I got the wiki page. It's a logistic function. Okay. And he literally tells you should look this up online. And then wiki will explain it for you. This helps a lot, actually. I don't know why I didn't get it at first, but this is so simple once you look at it. It's one of those things. Right? And
Did you post that
on
Go ahead.
on the test to look it up? What did you say? What did I post?
Did you ever send the link or no?
Oh, to my stream? No.
No. That's fine. I'm looking it up.
Well, I'm impressed if you find it. I don't know how you would. Oh, I have it in general. I posted the link in general.
Oh, okay. Yeah, I just didn't see it.
Okay. So here's he says, look up the logistic function. So first, just ignore 3i, right? You can ignore that. It's 1 over 1 plus 3 to the negative t. Then you go to the logistics function because he says look it up right here. And then Wikipedia is savage. They say it's easily calculated. I'll leave it to others to determine whether they're justified in saying that. But just rewrite it as this, because you just multiply everything by e to the x. It's kind of clever. And then the derivative is a little bit simpler from there, if that helps.
All right, I am back.
Oh, I can't go to Culver's tonight, Stefan. I've been going to bed earlier. But I will totally go sometime over this weekend if you're down. Hit me up. Tomorrow? No, probably not tomorrow. I'll probably be doing this.
Doing this tomorrow.
Yeah.
Believe it or not, we will probably be doing this tomorrow.
I mean, Culver's closes at like, what, 11?
10:30.
10:30? We can do this at Culver's. No, I can't get distracted like that. I can't
Plus
force
Culver's
myself.
isn't open.
It's not open? What? False.
Well, it's
drive-through.
the
Drive-through. Is it still
drive-through is
drive-through?
open, but the other thing is not.
Really?
Yeah, the dining room is not open.
Oh, I swear I've eaten in there. But anyways, do you understand a little bit? Nate?
What?
To get you going?
Yeah, I get it. I just haven't moved to do it yet. I think I gotta get up and walk for like 5 minutes or something.
Yeah, go do that.
I'll be back in just a little bit.
Y'all want to go for a walk together and like meet up?
What'd you say?
Y'all want to go for a walk?
Oh, I'm not Menominee.
Well, how far away are you?
I'm in Minnesota.
What?
Oh, where are you from? Where are you from?
I'm from Wisconsin, but also Wisconsin.
Okay.
But,
where are you in Minnesota?
I'm in Moose Lake.
Minch Lake?
Moose Lake?
Moose Lake? You know, I've heard
Yep.
of that. I feel like I should know where that is.
It's up by Cloquet.
This guy's mic is very percussive.
Are you being passive aggressive right now?
Yeah, always.
He muted his mic because of you. You're so mean.
LOL.
I already muted. Sorry, I forgot that it echoes sometimes.
Alright, back to the derivative. I gotta record this so I can move on to the next part. I should not be taking 30 minutes on taking derivatives. This is ridiculous. Alright.
I can't copy and paste into this. What? Trash.
Get out of town.
Absolute trash.
Is that what people say now? I'm a junior. I'm getting too old.
For what?
That's trash? I've never heard people say that.
What?
Absolute trash.
That's trash. It's funny though.
True. Time is at 6:46, so I have to wait until 8 o'clock. Okay.
Nate went to his cabin just so he didn't have to meet up with us today.
Yeah.
Sounds about right. Yeah, he just didn't want to have that potluck that we were all so hyped about.
Yeah, and then unfortunately because he couldn't come, I had to cancel.
That's what happened. Yeah.
Yeah, that's what happened.
I'm
Stefan,
sure
I
that's
don't
what
know.
that's what happened.
I don't know. What do you mean league highlights be coming here? I have a lot in my YouTube channel. Haven't posted recently. I've been coaching JK a lot lately, and I posted our 3-week progress. I think he's learning a lot. It's pretty exciting. But I won't be able to play for a little bit, so I won't be posting highlights for maybe 2 or 3 weeks.
What if I had told you we have to do yet one more derivative?
I'd be super happy because I know how to do them. Or I understand them right away.
Because we have to do one more derivative.
Okay. Perfect.
I'm glad you understand them because I'll let you do it.
All right, I'll be back in like 5 minutes.
Alrighty.
So what you were saying with the derivative is how on a Wikipedia page, like changing it over to what hit you there, and then taking the derivative to find the acceleration and velocity.
Yeah.
Okay. Yeah, that makes a lot more sense than doing it the other way.
Let me know if you're stuck anywhere. I'm still taking forever to write it down.
Yeah, I think I'm decent with derivatives, so I'll check with you once I get done.
Alright.
because like I almost feel like these ones are like trick questions, like because they're so like there's
Oh.
apparently they're extremely easy, like this derivative finding the acceleration of velocity.
And then this will be the one problem where I like misplace a negative or something,
Right, right.
or just
That sounds about right.
take
Honestly.
the derivative of the wrong value. It's because I wrote it wrong.
Yeah, because in the next question we have to find where its local maximum is,
Oh yeah.
or it's where it's fastest, which you have to do the second derivative test to do that. But the second derivative test applies when the original equation is velocity and not position. So we have to do one more derivative.
Alright.
You said that one more time. I didn't quite get it.
So for question 4.2 is asking about at what times does the t curve achieve maximum speed? That's not if I'm thinking about this right, the original equation he gives us is a position versus time graph, right? Am I right in assuming that?
I'm really in the zone right now. I will get back to you
Okay.
momentarily.
Well, I can't figure out the answer to the next one unless I have that answer, so I'll wait for you.
Okay. No, I'm really momentarily, like how you were taking a second earlier.
Yeah.
This
Except
is
for I was
faster
peeing,
than
but
that.
yeah.
Okay, I'm ready.
Okay, you ready?
Yeah.
Okay, so am I correct to assume that the original equation given in question in part 4 is a position time thing? Position time graph? If you were to graph it?
Yes.
So then
He
in
doesn't
4
say
point
so. Maybe it's the jerk, and we really should be integrating it twice.
It really
find the
doesn't say.
velocity. But I think
Okay.
we're pretty confident that he
Okay.
wants us to take the derivative.
Okay, so assuming that that is the position time graph, the second question is at what time t does the curve achieve maximum speed? In order to figure that out, we have to figure out the critical points of the second derivative of the speed of the speed.
Yep, and then you need to find out if it's positive or negative on the other side, and if it's positive on one side on the left side, negative on the right, then you know that is the point.
In which case we have to do the negative. No, well, that doesn't even matter. And at which point we have to determine one more derivative to figure out the second derivative of velocity.
Wait, we're still only on 4.1.
You're still on 4.1. I'm on 4.2.
Oh, I just finished writing it down. God. I promise I'll focus faster tomorrow.
So since we're taking like that 3i and the 3j or whatever it is out, and then when we bring it back in, how do we take the derivative of that? Like
of I and j?
Yeah. Is it anything different, or are they just constants?
You just plug those babies back in there.
Okay.
You don't even have to calculate the derivative.
Like that too.
What?
You have to say it like that too.
Plug those babies back in there. They left the outlet. You gotta plug them back in.
Is that you,
when you explain yourself on this question, when you have to explain the test answers
Woof.
in those videos. Oh, we have to make videos.
I finished writing it.
All right, because you have to do one more derivative.
All right.
And it's of the one you just did too.
What? No, you don't. Why? No, you don't. We already have the acceleration.
Yeah, but you need to figure out the jerk in order to figure out in order to do the
don't.
second derivative test. Yeah.
No,
Figure
you
out the yeah.
No, you
Yeah.
don't. At what time does t achieve maximum speed? In order, you only need to go one step further. He's asking for maximum speed, so you need to go one step down from velocity, and that's acceleration. When you're accelerating, when you're at no acceleration, then you're at constant speed. So we need to find out we need to find out, the critical points, as you said, and then we need to find out which critical point goes from a negative acceleration to a positive one. That critical point, well, that'll give us a set of critical points, but hopefully just one, will be the maximum speed.
Have you ever done
that point into the normal graph?
Yeah, but you could just make it easy and do the second derivative test.
What's the second derivative test? Is that not what I apologize. I don't.
Okay, give me a second. I'm gonna read up on it real quick here, but if I remember. We learned before that when x is a critical point of the function, we do not learn anything new about that function at that point. It could be increasing, decreasing, or local maximum and local. We can often use the second derivative of the function, however, to find out when x is at a local maximum or local minimum. Recall that x is a critical point of a function when the slope of the function is 0 at that point. Now, suppose that x is a critical point and the second derivative of the function is at that point is positive. The positive second derivative at x tells us that the derivative at Sx of f of x is increasing at that point, and graphically that the curve of the graph is concave up at that point. The only way to sketch the graph of a function at a point where the slope of the function is 0 but the graph is concave up is to make that point a local minimum. So if x
that's what I just said. I literally just said that.
Yeah, but
I just didn't say concave down.
Yeah, but if you know where you can use it. Okay, so literally the second derivative test, all you got to do is plug in the number. If it's positive, it's at a local minimum. If it's negative, it's at a local maximum. Compared to doing different tests on either side of the local max or local min.
What numbers do you want to plug in? Because it's negative infinity to positive infinity.
We just have to find the critical points. So wherever the
No, set the acceleration equal to 0.
How do you find critical points?
Set the acceleration equal to 0.
Yeah, you're right. When and then you plug those.
Not accelerating, then it's at a constant speed. Oh,
didn't you say that already?
Yeah, no, I did. I am repeating myself, but it's like sometimes it's more for myself than for you guys.
Yeah. Okay. So when it's at a critical point, you're correct.
I can't believe we're talking about this. I swear to God, I've studied critical points for 3 years. I've taken 3 calculus courses. All right. I should know this.
I promise that if we do the derivative one more time and then we find the critical points of f of the derivative of the first one, so the acceleration, then we can plug those values in and see where it's at a local max.
We should not be struggling with this.
What? Yeah, I know.
Am I the only one feeling this?
No, you're really not. But
well, I mean, I think we should, we don't have to be perfect.
Modern problems require modern solutions.
What does that have to do with this?
What does it not have to do with this? Isaac Newton could do it. I can't.
And it stops there.
Yeah, that's it. That's it.
That's the end of my TED Talk. What? You guys want to watch a TED Talk break with me? I think we maybe. Well,
Yeah, I
don't
still
know.
haven't picked up my pencil.
Yeah,
I'm
okay.
drained from that
TED Talk.
fucking
TED
shit.
Talk break.
I wanna see this email that this guy sent. Where? Oh, okay. Let's see. Okay.
My
Please see
It's
this
nothing
video.
special.
analysis teacher said to watch the TED Talk that says starts with Y.
So if I put this video at 2 times speed, I can finish this in 10 minutes.
Yep.
Did
You might as
already-
well. You don't need to actually like sit there and listen to it.
Yeah, Nate, I saw what you put in the group chat for number 2 for 2.4, and oh my god.
Yeah, that one took me a while. I kept fucking it up.
Is
So I
it
had to
more
keep
than one page
redoing it.
long?
No, it's like 1 page. But it took me like 3 or 4. I kept messing it up, dude. I couldn't figure out what the hell to do.
So how the hell did you do it? That's my question.
I mean, it's just. Have you done like the other problems of 2?
Yeah.
I mean, it's kind of like the same concept.
Okay. Yeah,
You just take.
Okay. Did I post the link in Discord? Would you guys be willing to watch it with me? Because
Watch what?
watch the TED Talk with me for just a break. My analysis teacher said this is a good one. Well, he's always saying what stuff we could be looking into. So this is the one he said today. I'm watching it soon. All right, I'm watching it.
So where do you start
Let me know if you guys want to join.
when you have a program that's about integrating life's passions? Well, you start with why. Why? And that kicks us off for the first speaker tonight, Simon Sinek, in his talk, Start with Why.
We assume even we know why we do what we do. But then how do you explain when things don't go as we assume? Or better, how do you explain when others are able to achieve things that seem to defy all of the assumptions? For example, why is Apple so innovative? Year after year after year after year, they're more innovative than all their competition. And yet they're just a computer company. They're just like everyone else. They have the same access to the same talent, the same agencies, the same consultants, the same media. Then why is it that they seem to have something different? Why is it that Martin Luther King led the civil rights movement? He wasn't the only man who suffered in a pre-civil rights America, and he certainly wasn't the only great orator of the day. Why him? And why is it that the Wright brothers were able to figure out controlled powered manned flight when there were certainly other teams who were better qualified, better funded, and they didn't achieve powered manned flight, and the Wright brothers beat them to it? There's something else at play here. About 3.5 years ago, I made a discovery, and this discovery profoundly changed my view on how I thought the world worked, and it even profoundly changed the way in which I operate in it. As it turns out, there's a pattern. As it turns out, all the great and inspiring leaders and organizations in the world, whether it's Apple or Martin Luther King or the Wright brothers, they all think, act, and communicate the exact same way, and it's the complete opposite to everyone else. All I did was codify it. And it's probably the world's simplest idea. I call it the golden circle. Why, how, what? This little idea explains why some organizations and some leaders are able to inspire where others aren't. Let me define the terms really quickly. Every single person, every single organization on the planet knows what they do, 100%. Some
Did
know
this
how
guy
they do it.
seriously
Whether you call it
say
your differentiating
that he
value
would be
proposition or
amazed
your proprietary
if
process
somebody
or
got a
USP?
90% on the
But very,
test?
very few
Yes.
organizations
What?
know why they do what they do. And by
His
why, I
job
don't
is
mean
a
to make a
coach,
profit.
too. He
That's a
needs to be
result.
inspiring,
It's always a
and it
result.
need-
By why,
he's-
I mean what's your
he's
purpose?
trying to put
what's
value in
your
what
cause?
we
What's
do.
your belief?
right?
Why
And
does your
so
organization...
Life
they
isn't
very
variable,
well
isn't it?
believe
Well, as a
that
result,
some
the way
of
we
us could
think,
ace
the way
it,
we
right?
act, the way we
But
communicate
the
is from the
intent,
outside in. It's
I
obvious. We
suspect
go from
at
the
least,
clearest
is
thing
to
to the
inspire
fuzziest
us.
thing.
And saying something
But the
like that
inspired
is
leaders
quite
and the
inspiring.
inspired organizations,
When
regardless
you
of
say
their
it like
size,
5
regardless-
times,
Intimidating.
that-
Did I
Actually
sound
communicate
intimidating? I
from the inside out.
apologize.
No, you just sounded intimidating, right?
I use Apple because
When you
understand
say, oh yeah,
it
nobody's
gets it.
gonna, I don't
If
expect
Apple
anybody to pass
were
this
like
test
everyone
like 6
else-
times.
Oh,
A marketing
20
statement
minutes?
might sound
You're
like
saying
this.
he came out
We
as
make great
intimidating, 'cause
computers.
I didn't see it.
They're beautifully designed,
I didn't
simple to
listen to him.
use, and user-friendly. Want to buy one?
Nah, he's just the same old Abraham, bro.
And that's how most
Yeah.
of us communicate. That's how most
Okay.
marketing is done. That's how most
He's
sales is
just
done. And that's how most of us communicate interpersonally. We say
overly
what we do. We say how we're
talkative
different or how
about
we're better, and
nothing.
we expect some sort of behavior, a purchase, a vote, something like that. Here's our
Yeah,
new
he's
law
very
firm.
redundant.
We have the best lawyers with the biggest clients. We have
They're
we always
Abraham.
perform for our clients, do business with us. Here's our new car. It gets great gas mileage. It has leather seats. Buy our
You know, I
car.
could probably
But
use
it's
my
not
other
inspiring.
microphone and it would sound
Here's
a
how
little bit
Apple
better for you
actually
guys.
communicates.
Excuse me.
You shut fast.
Everything we do,
Don't worry about it.
we believe.
Yeah, this is probably a little bit better.
Status quo. We believe in thinking differently. The way we challenge the status quo is by making our products beautifully designed, simple to use, and user-friendly. We just happen to make great computers. Want to buy one?
Oh shit.
Totally different, right? You ready to buy a computer from me? All I did was reverse.
If only
the
I could do
information.
math
People
while
don't buy what
sleeping.
you do. People buy
Right.
why you do it. People don't buy what you do. They buy why you do it. This explains why every single person in this room is perfectly comfortable buying a computer from Apple. But we're also perfectly comfortable buying
Elon,
an
come out
MP3
with-
player from
with,
Apple, or a
um,
phone from Apple, or a DVR. from
Neuralink, please.
But as I said before, Apple's just a computer company. There's nothing that distinguishes them structurally from any of their competitors. Their competitors are all equally qualified to make all of these products. In fact, they tried. A few years ago, Gateway came out with flat screen TVs. They're eminently qualified to make flat screen TVs. They've been making flat screen monitors for years. Nobody bought one. Dell came out with MP3 players and PDAs. And they make great quality products, and they can make perfectly well-designed products, and nobody bought one. In fact, talking about it now, we can't even imagine buying an MP3 player from Dell. Why would you buy an MP3 player from a computer company? But we do it every day. People don't buy what you do, they buy why you do it. The goal is not to do business with everybody who needs what you
Is
have.
anybody actually doing math right now? Or are we all just like sitting here?
We're watching.
Sitting
We're
here.
watching.
Here's
I
the
said
best
we're
part.
watching a TED Talk.
None of what I'm telling
Oh
you
yeah,
is
when are we watching
it's all
this?
grounded in the
streaming
tenets
right
of
now.
biology, not
Oh.
psychology.
I watched it for a bit and then
If
we
you look at a
stopped.
cross-section of the human
That's all
brain,
right.
looking from the top down, what you see is the human brain is actually broken into three major
got distracted.
components that correlate perfectly with the golden circle. Our newest brain, our Homo sapien brain, our neocortex, corresponds with the what level. The neocortex is responsible for all of our rational and analytical thought and language. The middle two sections
Wait.
make up our limbic brains.
Uh-oh, I
Our
see
limbic
6
brain is
people.
responsible for all of our
My math
feelings,
teacher said
like trust
this.
and loyalty.
Why?
It's also
and it
responsible
turns
for
out
all
that
human
it starts
behavior,
with math,
all decision making,
And I'm starting
and
to
it
think I'm
has
not
no
watching the right
capacity
video.
for language.
but it's still good.
In other words, when we communicate from the outside
It's a
in,
TED Talk,
yes,
it can't
people
be
can
bad.
understand vast amounts
Yeah.
of complicated information like features
Oh,
and
that's a
benefits
lie.
and
I agree
facts
with
and
that
figures.
statement.
It just doesn't drive behavior. When we communicate from the inside out, we're talking directly to the part of the brain.
Okay, I think I'm gonna reconvene with all y'all at 8 o'clock.
Things we say and do. This is where
I'm gonna
gut
take a
feelings
solid,
come from.
like
Yeah,
maybe
sounds
a
good.
Sometimes you can
maybe a
get
mini
some of
nap
all
or
the facts and
something, where
figures
so I
and
can like
know
restore
and all
some
the
brain
things and
capacity
things,
of some
but
sort.
It just doesn't feel right.
Yeah, I
Why
might
would
do
we
the
use
same
that
next
verb?
week.
It
Sounds
doesn't
pretty
feel
good.
right.
I'll be
Because
back
we
on
control
at 8
decision
o'clock.
making,
How does that
doesn't
sound?
Control language.
Sounds good.
And the best we can muster up.
All right, I'll see you all at 8
doesn't
then.
feel right.
Okay, sounds
Or
good.
sometimes you say you're leading with your heart, or
I'll
you're leading
try.
with your soul. Well, I hate to break it to you. There's
I'll hop
body
off too.
parts
I'll
controlling your
hop back
behavior.
on his
It's
eight
all happening
as
here in
well.
your limbic brain, the part of the brain that controls decision
Sounds
making.
good.
and
See you
not
later.
language. But if you
Yeah, I'll be back at 8 too. I think I'm gonna go get some food so then I can actually focus because I'm so drained right now.
How will you ever get people to
How many
to-
people
to
are-
vote for you or buy something
many
from you?
people
Or
do
more
you
importantly,
buy?
be loyal.
Okay.
You want to be a part
Get
of
some
that.
food, be relaxed.
Again, the
I'll
goal
be
is
here
not
at
just
8
to
right
sell
now.
people who need
Yeah,
what
me
you have.
too.
The goal is to sell
I think it's a
people
good
who
time to
need what you
regroup
need.
or a couple
The
of
goal is
break.
not just to hire people who need a job.
All right,
It's
see you,
to hire
Colin.
people who
Bye.
believe what you believe. I always say that, there's if you hire people just because they can do a job, they'll work for your money. But if you hire people who believe what you believe, they work for you with blood and sweat and tears. And nowhere else is there a better example of this than with the Wright brothers. Most people don't know about Samuel Pierpont Langley. And back in the early 20th century, the pursuit of powered man flight was like the dot-com of the day. Everybody was trying it. And Samuel Pierpont Langley had what we assume to be the recipe for success. I mean, even now, you ask people, why did your product or why did your company fail? And people always give you the same permutation of the same three things. Undercapitalized, the wrong people, bad market conditions. It's always the same three things. So let's explore that. Samuel Pierpont Langley was given $50,000 by the War Department to figure out this flying machine. Money was no problem. He held a seat at Harvard and worked at the Smithsonian and was extremely well connected. He knew all the big minds of the day. He hired the best minds money could find, and the market conditions were fantastic. The New York Times followed him around everywhere, and everyone was rooting for Langley. And how come we've never heard of Samuel Pierpont Langley? A few hundred miles away in Dayton, Ohio, Orville and Wilbur Wright. They had none of what we consider to be the recipe for success. They had no money. They paid for their dream with the proceeds from their bicycle shop. Not a single person on the Wright brothers' team had a college education, not even Orville or Wilbur. And the New York Times followed them around nowhere. The difference was Orville and Wilbur were driven by a cause, by a purpose, by a belief. They believed that if they could figure out this flying machine, it'll change the course of the world. Samuel Pierpont Langley was different. He wanted to be rich and he wanted to be famous. He was in pursuit of the result. He was in pursuit of the riches. And lo and behold, look what happened. The people who believed in the Wright brothers' dream worked with them with blood and sweat
This guy
and tears.
sounds like a
The others
preacher.
just worked for the paycheck. And they tell stories
What
of how
does
every
this
time the
actually
Wright
end
brothers
up
went out,
being?
they would have to take 5 sets of parts because that's
About
how many
math?
times they would crash
No
before they
way.
came in for 0. They showed up for themselves. It's what they believed. The New York Times followed him around everywhere, and everyone was rooting for Langley. He wanted to be rich, and he wanted to be famous. No 3 came in for supper. And eventually, on December 17th, 1903, the Wright brothers took flight. And no one was there to even experience it. We found out about it a few days later. And further proof that Langley was motivated by the wrong thing, the day the Wright brothers took flight, he quit.
Yeah, we're taking a
He could have
test.
said, that's an amazing discovery, guys. Now we'll improve upon your technology. But he didn't. He wasn't first. He didn't get rich. He didn't get famous. He quit. People don't buy what you do, they buy why you do it. And if you talk about what you believe, you will attract those who believe what you believe. Well, why is it important to attract those who believe what you believe? Something called the law of diffusion of innovation. And if you don't know the law, you definitely know the terminology. The first 2.5% of our population are our innovators. The next 13.5% of our population are our early adopters. The next 34% are your early majority, your late majority, and your laggards. The only reason these people buy touch-tone phones is because you can't buy rotary phones anymore. We all sit at various places at various times on the scale, but what the law of diffusion of innovation tells us is that if you want mass market success or mass market acceptance of an idea, you cannot have it until you achieve this tipping point between 15 and 18% market penetration, and then the system tips. And I love asking businesses, what's your conversion on new business? And they love to tell you, oh, it's about 10%, proudly. Well, you can trip over 10% of the customers. We all have about 10% who just get it. That's how we describe them. right? That's like that gut feeling. Oh, they just get it. The problem is, how do you find the ones that just get it before you're doing business with them versus the ones who don't get it? So it's this here, this little gap that you have